Good morning and good afternoon again. This is Sean from Google. Today is March 25th, Wednesday. This is the Kubernetes Data Protection Working Group meeting. I already kicked off the recording. Later on, we will upload the video to YouTube. Today we have a couple of items we want to go through. I think let me open the doc. Unfortunately, I don't know why I cannot share if I'm hosting the meeting. If you guys can open that doc, that would be very helpful. The first thing that we have.
I can share that.
Please, thank you, Jane. All right. It has been a couple of weeks. Kanister has something to discuss, so she will be the first one to present. She has 10 minutes to go through some of the idea around having an interface to allow backup upgrades through the Kubernetes API. And then Tom from Kanister, we have invited him to give us a talk about how Kanister building blocks can be utilized within this data group, or maybe we can work together on some of those concepts. And third thing is that Ashish, we had a couple of discussions, Ashish from Valora, a couple of discussions around how they are utilizing the CSI snapshot to conduct backups for the cluster. Apparently, they are experiencing some not quite inconvenience features. We will also go through those features and collect some feedback from Ashish. And then we leave some more time. If we have more time, we can discuss more open issues. All right, let's get started. Kanister, it's all yours. Thanks, Shane, for sharing.
Yeah, hi, everybody. So I'm Kanister from VMware. And this came to mind for me some time ago, and I am actually trying to recollect what discussions were happening that I had this thought, but we also are considering the operation on backup, such as upgrade through Kubernetes versions. So it might be too early, or it might be out of context for this group. I'm not completely clear, but I figure I would throw the question out there. So what's in my mind is how backups are going to be represented through the interfaces and the operations on the backup, if upgrading a backup to be comparable as Kubernetes move up in versions, if that is something that this group should be thinking about. Maybe I'm not saying it should be right now, but if that is part of the context of this group, is my question.
Okay, Kanister, is there something you want to discuss specifically from your perspective? I understand, if I understand you correctly, you want to discuss the topic around Kubernetes cluster upgrade and how backups handling version. Is that what you want to achieve over here?
Sorry, you got a little bit cut off for me. So
okay,
having the operation on the backup, like let's say there is an existing backup. So, and they say, well, I want to take this existing backup and just make it compatible with this newer version of Kubernetes.
So when you say backup, do you mean backup of the entire cluster, or do you mean just the volume data, or what's the scope of that?
Yes, that is a great question. It would, and I'm not clear on how we are defining backup here in this group either. So it would be whatever the definition of backup that ends up.
Yeah, so at least my take is that if you are asking to restore the state of your cluster to a previous state, then that would inherently include the version of Kubernetes that you were at in that previous state. Having a separate, hey, let me go through and figure out what all the resources you had in the backup and upgrade them to the latest APIs and things, strikes me as a pretty challenging task. Volume data alone is a little bit different, but because presumably that could be done if you're willing to do that. But I don't know. So it begs the question, which is I assume where you're going with this, is that backups then implicitly, given the pace of Kubernetes, have a kind of shelf life.
Exactly. Yeah. Yeah. So I would have a question whether the volume will be included in this definition, but the resources definitely would be part of, at least what I'm thinking. So for example, if I want to restore a backup into a new cluster, but that cluster has a newer version of Kubernetes, I as a user would be grateful if I could just not have to upgrade my source cluster to the newest version, run another backup, and then do the restore.
So I guess the question is, what do you expect? Would that be a similar problem as when CRDs are upgraded and basically going through all of the resources and running through the webhooks that would upgrade them? Is that kind of how you're envisioning it?
I don't have a real vision for how it would happen. It's just something that we have discussed, and I was wondering if the group should be part of the solution for this API. But yeah, the upgrading the CRDs would definitely be part of it, I would imagine.
So I can give an example where this is kind of the thing. So if I remember right, with Postgres, like if you wanted to upgrade Postgres versions at one point, what you actually did was you did a PG dump, which put everything out basically into a text file as SQL commands. Then you'd create a new database that would have a new internal format, and then you'd play the PG dump into it. So that's one way, one model of looking at things, is that I'm upgrading my internal data structures, but I have kind of a neutral and compatible external format.
Yeah, if you assume that a cluster quote backup is effectively serialized YAML for the resources, then playing those back into the cluster should get the advantage of all of the upgrades that would happen normally, right? With the webhook. So I'm kind of wondering, and then there will be a set of those for which there needs to be some kind of manual activity because somebody didn't set up the auto mutation stuff. And I don't know how we set policy around that as a general rule.
Is there a general, like, what's the compatibility promises on Kubernetes?
As far as I know, from alpha to beta, there's no guarantee for backward compatibility. Even for beta features, Kubernetes can decide to retire it, but there's a 1 year period of time. For production, everybody should try their best to make sure it is backward compatible. If there's any API change or CRD change, which is not backward compatible, then a hook can be added into the API server such that it can be translated to the newer format. So from this perspective, I think to answer Kanister's question, somehow, in some sense, is that Kubernetes itself already have such a capability in most of the cases when you try to restore a lower version of backup into a higher version of Kubernetes cluster. There might be cases where certain CRDs are not backward compatible, but I'm just not clear how this working group can collect all this information and do an automatic version transferring based off of that.
Well, it may not be a matter of us defining that, but first we should at least look at the, is this something that is a reasonable use of backup and restore? And then if so, what constraints can we have on this? Where could we go with this? Because we can certainly see things like, Andrew's talking about volume data. Well, right now, like a restic backup would let you, for example, dump all your data out. If you had your data was in ext4 formatted volumes, you could dump it out using restic and then restore it into an XFS formatted volume. right? So there's those kind of upgrades and changes that might be interesting. Or if there's an etcd upgrade that's incompatible between the data formats, I don't know if that's going to happen, but you could see dumping all your YAMLs out and restoring them all back. I think the Kubernetes version is going to be tough.
Yeah, I feel volume data is slightly different than configuration data in this sense, because I'm not quite sure what is the upgrading concept in volume data, right? There is a format of transforming, as you mentioned, Dave, but what is the upgrading concept over here is normally connected with the application, not longer connected to the backup itself.
Yeah, let's be clear. I don't think anybody is suggesting that we upgrade database schema as a part of restoring a backup. I mean, that clearly is out of scope of a Kubernetes construct. That's an application specific thing.
Yeah, I think this discussion's scoped to just the Kubernetes YAML structures.
Exactly. I guess this is a very, very hard question. I guess anyone who is trying to do a backup and restore for Kubernetes resources will be facing this. It's a good topic to discuss, but just don't feel this 10 minutes is going to be meet or needs for that. Kanister, you want to take some action on this item, or maybe later on in later meetings we discuss this thing again. I hope you can also come up with some preliminary thoughts around what are the potential solutions we can provide, or we can, as a group, can suggest people to do.
And I joined a couple minutes late. Can we summarize the problem that we're trying to solve? Is it API compatibility between upgrades and how that affects storage? Am I rocking that right? Maybe Andrew, if you could.
Yeah, I think that the general question was a reaction to backups have the sense of having a limited shelf life, because if your cluster evolves after you've taken a backup, and in particular, if that evolution includes Kubernetes version upgrades, then what if anything do we need to do that a backup can be replayed into a cluster with, say, a higher Kubernetes version? And I think some of the summary of that is, well, some of that is just the normal backward compatibility guarantees that we have with Kubernetes, but of course those don't apply if you had alpha APIs you were using in the original cluster. And even with backward compatibility guarantees, you have to think that over a long enough time horizon, we will obsolete out interfaces. So there is always going to be some kind of shelf life. So I think the open question is, what, if anything, do we need to say about this? And that's what I think Sean asked.
Right. And so I thought the Valero team was doing some work around this issue.
We are.
Okay,
we
yeah.
are. So like our 1.3 release, we had some issues with CRDs going GA with structural schema translations. So even though some of the I think some of the compatibility guarantees weren't necessarily concrete there, we are doing some translations for users. And in other cases, we're just saying, okay, we're going to back up the V1 beta 1 version and restore the V1 beta 1 version. I'm not remembering the details there now. Also, we have someone exploring doing mappings of various, he's got a table of various versions of the built-in API groups on different versions of Kubernetes and where they overlap and things like that. And we're exploring changing Valero so that it backs up all versions of a given API group instead of just server preferred, so that we can possibly refer, if we restore into a cluster that has, that is missing the backed up API version, we can try to upgrade it to the highest known. But that's all like very early right now.
So that would actually be a case where you're restoring theoretically into a lower version cluster.
This is Raphael. Lower and higher.
Lower and high, yeah.
Yeah,
If it aged out is what I'm thinking.
Got it. Right. So you don't. So right. So it has the last 3 versions, say, in the new cluster, but you need the 4th back.
Right. Yeah, Raphael is the one that's actually doing the work.
Yeah.
I also kind of noticed that the preferred version is usually the highest. And so I think that comment does stand where if you're backing up everything, if you're only backing up server preferred, you have the latest version possible in that cluster. But then if you want to restore into an older cluster, you want the older versions as well.
It's like, go ahead, Raphael.
I think the challenge is as Kubernetes grows popularity, you have many more API groups. It's kind of like difficult to make those assumptions. I'll give the example of the outscaling group, which V1 is the preferred, but a lot of people using V2 beta too. So it basically, we breaking out this problem in 2 steps. One is first take a backup of all versions, and then the second step will be coming up with the logic, how we're gonna make decisions to restore the groups based on versions. Does it make sense? Oh, it's a certain way very interesting, but I'm very curious how you infer desired version from that. Are you inferring the desired version of a certain resource from the cluster version, or because they are implicit dependency inside those versions, right? Yeah. If I break out the 2 major categories of API group, is one native to Kubernetes, which is part of API server, right? Today is around 20 groups, depends where the version you are. And then another category will be the API groups that the other products outside of native Kubernetes create. I think that's gonna be a great conversation to the community, and give some options how people can decide to restore those API groups. We can have some defaults, we can have some options to people give the parameters and so on.
Doing a time check here. I think we are almost 20 minutes past
Yep.
hour. So
Yep.
should we come back to this topic? Can you guys maybe put together some slides and summarize the problem, and then what are the challenges, and we can maybe have a longer time slot to talk about this next time?
Yeah, I definitely agree. I think what Nora and Raphael was describing was pretty interesting, and the experience in this space can definitely benefit this group. Do you guys, and Kanister, do you guys want to take an action item on this and maybe present back later on to the group how you solve this problem and what kind of challenges you're facing right over there with regarding to the version? Hi, this is Raphael. Yeah, I can take an action item, and I'll work with Nolan and Kanister to do that. Absolutely. Sounds good.
Yeah, thank you. I mainly today wanted to do a temperature check and see if this was of common interest. So we'll do that.
It is still challenging. Definitely everybody is facing. All right, thanks. All right, next item, Tom, it's all yours now.
Thank you. Do you mind if I share some slides? Can I?
Sure, please go ahead.
Thank you. Let's see, Chrome. So we've been working on a project called Kanister for the past almost 3 years at this point, been around 2.5. And we have a kind of a deep background in data protection. And so I wanted to bring some of the learnings from Kanister to this group and see if there's kind of a path forward with parts of Kanister being used in this group as well. So first, what I want to do is go through the learnings. Let me present. Full screen. Sorry, I don't usually use slides. 5. Oh, I lost my, I think Zoom is blocking my, 1 second. I can go through it like this. But first, what I'll do is start with the learnings that we have with Kanister, and then we can kind of go from there. So what we've noticed about data protection workflows is that they often require application-specific playbooks. And so I'll give some examples of that. Dave actually mentioned one this morning with Postgres, which is a great example. I think data protection is not just limited to backing up and restoring data, but also kind of as part of other larger workflows like doing schema changes and upgrades. And so an example of what you would need to do that would be taking a logical backup. So a lot of different databases have tools that would help you do that. So a lot of dump type tools that extract data at the logical level. Other workflows include using, for example, cloud provider API calls. So an example here would be RDS. I can take snapshots of an RDS instance. I may also want to use something like an operator and create CRs, custom resources, as my API call. There may also be smaller components within data protection workflows. So things like doing application-specific quiesce, unquiesce. I know that we've talked here about doing more generic ones for volumes. So doing like a FS freeze, unfreeze. But in many cases, it makes more sense to use application-specific quiesce, unquiesce, because you may need fewer permissions, right? It can be part of your app owner's workflow rather than kind of a system admin's workflow. An example there would be like a flush tables with relock for MySQL, which would give you a consistent view of the MySQL instance's data. There's also more advanced scenarios, some of which we've also discussed here. I know Andrew's talked about taking backups from secondaries, which is a great use case. You know, a lot of people often, if you're taking a backup of your cluster, don't want to put too much load on your primary instances. The other learning is that, as we've kind of just mentioned, data protection workflows can be quite complex. One thing that adds this complexity is the many different domains you have to deal with and the different types of personas in those domains. So you often will have kind of Kubernetes cluster admins who are different than your application developers, who may be different than your service experts, in some cases DBAs. And I think each of these domains often will play a part in data protection. And so you may not have all the expertise kind of in one small group to execute these. And so there requires some coordination. In addition, there's many kind of infrastructure moving parts as well. So you can back up to many different places. You know, object store, there's a lot of vendor specific targets that you can back up to. As mentioned earlier, there's many different types of backups that use different parts of your infrastructure. And in the new
Did anybody else just lose him, or is it just me?
Yeah, no, it was me.
Yeah.
Can't hear
I
anything.
can't hear it.
Yeah, me too.
I hear you.
I think Tom, are you still there? Let's give him maybe 1 minute to see what's going on. Thanks, Comcast. Oh, my Comcast still holding up over here.
I see him on Slack, so I'm just pinging him there.
Okay, good. Thanks.
I'm still waiting for my gigabit fiber that AT&T keeps saying we can get.
Oh, I don't have AT&T coverage in my area, unfortunately.
Yeah, me neither.
Yeah, they only cover very limited places at this point.
I have gig Ethernet at home, but even though the bandwidth measurement on it is phenomenal, I'm seeing terrible latency issues on even on Zoom.
Yeah.
It's interesting that you use the word even on Zoom. I guess Zoom is probably one of the most heavy thing you're gonna use in your network, no?
I say even on Zoom because I've been using other methods of communicating and nothing has been able to sustain connections as well as Zoom.
I see.
Yeah, Zoom has been flawless for me.
All right. I didn't see Tom.
Yeah,
joining yet.
I got a message from his phone saying he lost Wi-Fi.
Oh,
Now, will he be able to use his phone, or somebody else can share the screen? Does that work? Does the phone still work, right?
oh yeah, that could be a potential solution. Xin, I think you have his slides, right?
Yeah, I can
share.
yeah, I can.
Yeah, let me tell him to dial in from phone.
We can do the sharing.
Okay. I can share.
Yeah, he said he's calling in.
Perfect, thanks. Tom, was that you? Nope.
No, that's probably my phone.
Oh, okay. I saw him online now. Yeah, he's not online. Maybe he will join.
Hey, sorry about that. Can you guys hear me okay?
Yeah, we were talking about, are you using Comcast at home?
Yeah, I am.
Okay.
I lost it.
Okay,
I know,
go ahead.
I think Comcast is a bit overwhelmed right now, so.
Yeah, go ahead.
Can you see the screen?
I can, yeah. So if
Okay.
you're okay with showing these, then I can keep going.
Yeah. Is this the, you want to go to next page or?
Next slide, please.
Okay. Hold on, wait. Okay, yeah.
And I think I got halfway through this one, so I can keep going here. We've also noticed that there's a lot of kind of
We
common.
didn't get to the slide.
Oh, we didn't get through the last one?
We lost you before you switched to the slide.
Okay. Jing, could you go back? I'm sorry.
Yeah.
Thank you. Where did I go through the quiesce unquiesce yet?
Yeah, you finished this slide.
Okay, perfect. So then next slide, sorry.
It's okay.
We've also noticed that there's a lot of different data protection primitives that are common across different workflows. And so there are a lot of things like in Kubernetes execing into a container. I know that Jing, your work on, for example, execution hooks is kind of a good example here of something that's very useful. We've also seen a lot of pushing to object storage in different ways, either directly or through, for example, Valero uses RESTIC. Obviously, taking volume snapshots is very useful. A lot of great work with the snapshot controller, for example, but also using in-tree providers supporting. We have a lot of customers who still use those. And of course, controlling the lifecycle of your application through commands, through kubectl type commands like scale up and scale down. Next slide, please. And so some of the motivation we have, actually, Jing, I think you're on an older version of these slides.
Oh.
I changed it slightly, sorry.
I thought this is the one in Google Slides.
No, the final version. There's a final version.
Oh, it's not the, okay, let me, hold on, then let me, draft. Okay, so hold on, let me go find.
If Tom, you already have your network back, maybe you can share as well.
My network is still down.
Okay,
Oh, okay.
so just give me a minute. I need to find your.
The
You
email
sent
is
it out
last.
yesterday, right? You sent.
Yeah,
I think
last
you
night.
sent out.
I think the link in the Google Doc is up to date, but.
Okay, so but then that's, oh, you have two. Okay, you have a draft and you have both there. Maybe that's why I just clicked on. All right, I think this one is the new one. Let me share again. This is the new one.
This is it, yeah.
Okay, where are we now? This page?
Right here, perfect, yeah.
Okay.
And so based on kind of all of these things we've noticed in the data protection workflows and community, we set some goals that for building a project that would help us fulfill these meet these requirements. So one thing we wanted to do was codify all these workflows in a common place. So this means both pulling from the community as well as within a company having kind of a set of resources that people can use. And of course, we want to make this work in a cloud native way. We also wanted to make these very easy to extend, right? Hopefully, if you want to customize something, it can require only minor tweaking. And of course, all this should be done through APIs that could be invoked through, for example, data protection controller. I know, for example, a lot of people here have been thinking about what a data protection controller would look like, how if we define a common set of APIs that we can input controllers that would go and respond to those APIs. And for us, what we want to do is make sure we separate the definition of what the workflows were from how to invoke them to kind of match the different personas in the community. Next slide, please. We also had a set of non-goals. So a common question that Sean has been asking is the definition of an application. Kanister is actually pretty unopinionated here. There's a lot of kind of existing definitions, but from the Kanister perspective, all these different definitions map to a group of resources. And so if you look at like the application CRD or Helm charts, really what they are is a collection of different resources. And from the Kanister perspective, we want to support all these different types of groupings. Rather than support kind of these broader definitions, right? We didn't want to have a strong opinion on which one.
I lost you again. Tom? Yeah, he dropped that.
Yeah.
Schema change. Yeah.
Oh, he's back? He's back. Tom?
Did I get cut again?
Yes.
Yeah.
Oh my gosh, I might disconnect from Wi-Fi completely on my phone even. Yeah, I think my phone's connecting and disconnecting from Wi-Fi, so maybe I'll just turn it off. Okay. Did you hear? Was I able to go through the application part here?
Yes. The first one, right? The first bullet, I think you're done. I think
Yeah,
you're talking about the second one.
Tom, I have a quick question. When you say you support existing application constructs,
yeah,
and I know it's a quick deep dive, but do you do it by listing resources in a manifest? Do you do it by label selector? How do you do that grouping? Obviously, you say that you allow multiple different, but there still has to be a way to point to that.
Absolutely. And so from the Kanister perspective, we actually only operate on individual resources. And essentially you pass in these resources as you execute actions on these resources through Kanister. It's up to what we call an application data protection controller to define what that grouping maps to, right? So from the Kanister open source perspective, really the subject of any action is a single resource. And from that resource, you can, for example, a workload, you operate on that specific workload through Kanister, whatever your higher level grouping is, and how that maps to different resources I think Kanister doesn't have an opinion on.
So you can't take like any CRD and figure out what is in there. You have to know. The CRD has to tell you like what are the volumes there and what are other resources.
So there are some special cases. You know, a CR is also a resource that you can work on. A workload usually has volumes associated with it, and so we do kind of fan out and figure out which volumes are part of a workload. But in terms of, let's say if I have a namespace which has many resources, Kanister will operate on those one at a time. And this kind of maps to something that, I actually have some slides on this later, but this maps to something that Dave Smith has talked about in the past a little bit, which is more of a bottoms-up approach rather than a top-down approach, which lets each individual object kind of define how it should be backed up. And maybe those are higher level objects, like a workload, for example, like a stateful setter deployment.
Yeah, and that those objects could even be even higher level than that, right? So you could say if my namespace is an application, you could describe the workflow for that namespace using Kanister.
Absolutely, yeah. And I do have a slide on this a little bit later too, which I can jump into. But
yeah,
I think
we can talk about that later. Yeah, it's fine.
Yeah, I think in terms of the specific question, right, it's maybe the answer isn't too satisfying because Kanister really focuses on individual resources. And you know, I think we have varying support for higher level constructs like namespaces or workloads. You know, but we could talk about adding support for the app CRD or Helm charts. But you know, I think it's still focused on individual resources.
I guess, Tom, most of the question over here is around when you say individual resources, they say stateful set, right? It contains not only itself, but all the PVCs that would be created by the PVC template, if it has any.
That's
I guess
right.
most of the question relies on how do you figure out those support.
So stateful, we essentially have a fan out mechanism. Stateful sets are a little bit easier because we kind of just query the PVCs associated with that stateful set. But
so
otherwise,
do you have knowledge of the individual controllers? So this is a hard-coded, if I'm dealing with stateful set, this is how I traverse it. If I'm dealing with a deployment, this is how I traverse it. Is that the idea?
That's exactly right, yeah. Which, you know, I think we like to generalize, but we found for those type of workloads, like that works pretty well. Okay, great. Yeah, I think this is a good question and something that we can keep talking about. But for us, you know, I think there's kind of things that we think belong in essentially a data protection controller. And there are things that belong inside Kanister. And so I think defining the application, we pushed up to the data protection controller. And the other thing we pushed there also was handling the actual contents of resources. So the configuration path, we think belongs inside the data protection controller. And a lot of this is because, you know, I think there's already implementations for this, but also there's a lot of different ways you could deploy this configuration, you know, through Helm charts or through Git ops, for example. You know, most companies already have a mechanism for managing the API objects themselves.
I'm sorry, I'm getting a little bit lost in the abstractions, so I'm going to ask a couple questions if you don't mind. So one of the things that presumably you have to do is hook definitions, and the thing about hook definitions is there might be multiple containers in multiple pods that you required fairly complicated orchestration. And so to even do that, you kind of have to know what are all of the pods that are part of this general space. And you have to have logic to be able to identify pods and containers. So container name, pod selector, something like that. Yet, if you're
Absolutely.
not dealing with the configuration, I don't know how you do that here. So I'm missing something.
When I say dealing with the configuration, I really mean avoiding backing up the configuration and restoring it, right? I think for example, Valero has an approach which is similar to K10's approach, which will use essentially discovery to go figure out what the objects are, back up all the specs, including, it looks like, multiple versions of those specs, those configs right now, and restore them. So we push that off. We don't think that belongs in Kanister.
I guess the question I have is, how do you ensure that the domain, that the boundary of the application is agreed upon both by the Kanister and the DP controller? Like, how do you reason about, here's an application and this is how I back it up, if you don't have a consistent view of what the scope of that is? That's my concern.
The typical pattern we see for applications is that you'll have a deployment or stateful set that maps to your database, and so you can get a consistent view of your database. Or you, for example, have a single workload that maps to the group of volumes that you have to make consistent, and so you can work on individual workloads themselves. If you need to coordinate multiple things, that is possible as well, but that's not really the common case we see. Are you thinking of an example?
Well, you gave an example of namespace being a possible definition of an application. Or
Sure, yeah.
You could imagine a multi-moving part app, like say a WordPress install that's got a web server bit and it has a database bit, and so I have coordination. So I kind of really need to know, oh, I'm doing this one and then I'm doing this one, and these individually need to be consistent, but don't increase the domain of consistency across both instances of this, because
Tom, I think your next few slides would probably make this a little clearer. So maybe once we go through the example, it might make things a little clearer here.
I think it's a good idea, yeah. And I will say WordPress, or there's kind of a picture gallery from the community that is a good example, because they're pretty typical web apps, right? They have components that are kind of common across different systems. But I think it's a good. Maybe Andrew, I can go through the next few slides, and if we can follow up after, because I think it's a good question and something that we really think about a lot. Okay, Jing, can you please next slide? So really, from these kind of requirements, we built Kanister. One view of Kanister is one thing Kanister can do is do full backups and restore, or just backup and restore hooks. And this all goes through custom resources. So there's a standard set of ways to create an action. We call these action sets. Again, a custom resource. And there's a custom resource called a blueprint, which defines the workflows. Again, the subject of these is individual resources. And so workloads and potentially higher level concepts like namespaces, and in future we plan to add support for Helm charts and application CRDs. What we do inside the blueprints is we actually use Go templating, so that you can, given an object, consume different instances, have different instances of an object be the subject for a blueprint, in a way that lets you write a blueprint once and then handle kind of any instance of that type. So for example, if I have a standard definition in my company of what MongoDB looks like, for example, I have a Helm chart that people commonly use, I can create a blueprint for that Helm chart, and then for any instance of that Helm chart, any release of that Helm chart, I can use the same blueprint because I have access to templating. And what we've also done is added a bunch of helpers, what we call Kanister Functions, that have kind of implemented a bunch of the common primitives you need for data protection workflows. One example would be, if you want to invoke the common kind of kubectl functions, for example, kubectl exec or run, right? We have helpers that make it easy to include these in your blueprints. And, so you can, you don't have to repeat a bunch of the work in different domains. Next slide, please, Zhang. So this, I'll go through a blueprint here. This is a simpler app because it's just a database. What we usually see though is that if you can get a consistent snapshot of your database, then you can, you actually kind of can achieve a consistent backup application. I don't have an example of a more complex app that, for example, maybe needs some volume state as well as state in a database. But typically cloud native applications will handle that kind of in an okay way. But I'll run through this kind of example pretty quickly because I know we're pressed for time here. So a blueprint is a CR. There's the kind of the standard CR boilerplate. So it exists in the same namespace as a Kanister controller and has a name. Next slide, please. There's a set of actions inside a blueprint. In this case, the action is named backup, and this action operates on a stateful set. Next slide, please. What we defined in blueprints is output artifacts. So usually when you take a backup, you have to put it somewhere. We left this pretty general, but a common case is pushing to object storage. And so here we have a path. Once you've created a bucket, we have a path inside that bucket. Next slide, please. And we have a set of actions to perform. We call these phases. In this case, we're invoking a Kanister function called kubetask, which will run a new pod. The namespace field here, if you see, is templated. And so we want to handle the object in the same namespace as a stateful set because we're actually working on that stateful set. And we're running an image which has whatever tools we need. In this case, we're running a shell script. We found that it's pretty common that a lot of admins like to write shell scripts or port shell scripts from their existing infrastructure. And in this case, we're running Mongo dump. And this is a bit simplified, but we have a link for kind of the full example at the end.
So I think, Andrew, this might be a good place to just quickly answer your question about discovering the components of a specific workload, for example. So when Kanister knows that you're invoking an action on a stateful set, it makes available the components of the stateful set as template parameters. So all the pods that are part of that stateful set, all the PVCs that are part of that stateful set, and then the blueprint author has an option of referencing those in the blueprint. For example, if you want to invoke a specific command only on the first replica of a stateful set, you now have the ability to do that as well.
Yeah, I'm a little lost here, how you know where to run. I mean, the command, the bash command here, it's not clear to me where that's supposed to run. Oh, is image a container reference? So you're saying run that in the whatever container has that image?
That's right. Yeah. So we're running spinning up a new pod with that image. And the reason we do that is because that image has whatever client tools we need.
Oh, you're spinning up a new pod.
So the function, if you look at the function there, that the Kanister function you're using, it's a kubetask function. So this says spin up this image and run that command. There are other functions like kubexec in which you can specify a specific pod or container you want to run the command in.
Okay, so again, I guess I'm a little lost here because, okay, so it's spinning up a new pod. How does it, so it's not, so something magic in that Mongo figures out how to attach to your existing Mongo cluster. I guess, is that what the -- host and that stuff is for?
This is actually this is very simplified. And so we kind of omitted a lot of the details here. At the end, I have a link with the full blueprint, which is a lot more complex and includes things like how you pull info from the service to get the host name. It includes a little bit more information on maybe even like the service account used to run the pod. So I think this is very simplified, mostly so I can fit it on one slide. But maybe offline we can follow up and I can send you a link to the full blueprint.
Great, thanks.
Okay, sounds good. Thank you. Great questions. Next slide, please. So similar to a blueprint, we have an action set. An action set will be how we invoke that blueprint. And for example, if I want to take a backup, I'll create the action set. Similar to the blueprint or any other custom resource, we have all the required boilerplate. We typically like to generate the name so you can use the same action set and create it multiple times. Next slide, please. An action set has a spec and a status. So in the spec, you define the action you want to run inside a blueprint. So here we have a reference to a blueprint as well as the action within the blueprint we want to run. Next slide, please. It also references a specific object, a specific resource. So here we're referencing the stateful set that we want to perform the backup on. And this, if let's say multiple instances of Mongo deployed, you would just change, for example, the namespace or the name of this reference. Next slide, please. And what we do at the end is once the action completes, we kind of update the status with any errors that occurred. Or in this case, we actually succeeded and we created a set of artifacts. So the action set, after it's completed, will contain all the artifacts created during that execution of the blueprint. Next slide, please. So I have a walkthrough here. I know we're a bit over time, so maybe we can skip ahead a little bit. Because I want to go through some of the features that Kanister has, but just until after the execution walkthrough, we'll kind of skip this here.
Hey Tom, I have a quick question.
So
is the idea that the blueprint is like a common set of primitives to deal with certain kinds of applications? Let's say like one kind of template of or a standard operating procedure to back up, say, Mongo.
Exactly. So usually what we see is if I have a database, I'll have one blueprint for that type of database. Most companies will deploy, say, Mongo from a Helm chart or Mongo from like an OpenShift template. And within that company, we'd hope that you have mostly one blueprint for Mongo. And then you could, multiple users could use the same blueprint. And let's say my application requires multiple pieces. Maybe it has a Mongo database. Maybe it has a volume. In the case of an application, more complex applications, you could have parts that need some configuration on a volume. You could do things like try to freeze that file system if you have to through a blueprint, but keep the blueprint for backing up Mongo separate.
Time check right now. We only have 6 minutes. Shish, do you mind if we move your snapshot experience to next session?
Sure.
Because we only have 6 minutes over here. I doubt you can finish your issues as well. Okay.
Yeah, that's good.
All right, cool. Tom, you have 6 more minutes for you then.
Thank you. And I apologize, Ashish. I was actually looking forward to what you had to say. But,
yeah, no problem. We can wait.
Okay. Yeah. So I'll kind of just wrap up pretty quickly. If you could, next slide, please. Perfect. So I wanted to just quickly go through the primitives that Kanister has. The primitives are kind of the core components that you compose to build your blueprints. Because I think these are common across a lot of data protection workflows. So the most powerful ones are the really kind of most flexible ones like kubeexec or kubetask, which will help you spin up pods to run actions or exec into existing containers. We also have helpers that help you manipulate resources. So although we're not backing up the configuration directly, often as part of workflows, you'll have to modify the resources. So you might scale them up, scale them down. You might have to run arbitrary kubectl commands to modify their contents as well. Of course, in data protection, you have to work with volumes. And so we have a bunch of handlers for PVCs. I'll talk about the things we support there in a little bit. But basically, you can back up and restore data to object storage from PVC. We've also found that some workflows require mounting a volume and performing some action on it. For example, let's say I've done a hard stop of MySQL and I want to make it crash consistent. maybe I have to mount that to a pod and run the backup recovery tools to replay the log for that MySQL instance, for example, through the helper for that called prepare data. We also make it easy to take cloud snapshots or volume snapshots with simple helpers to do that. And there's kind of two flavors of that. I'll kind of punch on that for now. And finally, like if you're using resources outside your cluster, for example, RDS instances, we have helpers for that as well. The two main ones there are back and restore, and we've also have helper for copying between different regions, which is kind of, we've also seen as a common workflow in data protection use cases. In terms of what we support kind of the three big cloud providers object stores, and we also support S3 compliant object stores, which is kind of the rest of them. For example, Minio, you can access through there as well. For block and file, a lot of our customers actually still are using in-tree provisioners. And so we have kind of under the covers integrations with those providers, as well as supporting CSI. Right now, we're still supporting the Alpha Snapshot API group, but we're working on trying to support both. And I had some questions, Jing, for you there, but we can follow up maybe later.
Tom, I have a quick question.
Yeah.
In your customer logic, where you can actually spawn a pod to conduct a kube task, right? And from time to time, this task will report back to you a file, a zip file from your example. So as an upper level orchestrator, let's say a data protection controller, whatever you call it, it needs to know where and how to load that file and somehow put it somewhere, right?
Yeah.
In this case, if your pod is a task, it's a Kubernetes job or something that once it's gone, you lost everything from it. How does the controller have access to those files if needed?
Great question. It's a little bit deep. I don't know if I can answer that in 2 minutes, but essentially every Kanister function can create a set of outputs. Those outputs are just in a string format, so they can either be a JSON string or a string here. In this case, for that question, commonly what we see is paths in object storage, which are references to the data you've pushed. And so the controller will have to somehow understand that type of artifact. Or in some cases, maybe it doesn't, right? Maybe you can treat it entirely as a Kanister abstraction, where Kanister will know how to handle whatever string it produces. So if I write a blueprint that does backup restore, the backup can produce a reference to something, and then the restore will know how to handle that reference, right? And so if the controller is running backup and restore, all the handling of the specific artifacts is done by Kanister.
But will all the tasks share the same object bucket, if object store?
There's something I didn't get into, which is configuration, and there's another CR, another custom resource for handling object store configuration. We call them profiles, but I didn't include that in these slides.
I see.
But great questions. Next slide, please. Skip this one, please. Skip this one. So to wrap up, I just want to talk about what we kind of envision for the rest of Kanister. I think that the model maps pretty closely to execution hooks, since we'd love to kind of maybe work with Jing to get integrate Kanister with some of those. I think we're trying to solve some of the same set of problems, so it'd be good to kind of collaborate there. We also want to continue to have Kanister support whatever workflows the working group comes up with. I think kind of having a back and forth on those would be really useful for Kanister and the rest of the community. There's also some kind of more community building we want to do around Kanister. I think the blueprints that we write and that others have written would be useful for the community at large, and getting more input and feedback on those, right? Database experts to help with that. At the end, I have a full list of all the kind of blessed blueprints we have. We have customers who are using internal blueprints that they haven't open sourced, but we have a growing list of open source ones as well. And of course, we want to integrate Kanister with more of the data protection controllers. So that will come out of this working group. Right now, it's integrated with Kasten's K10, but I think it would be useful for other controllers as well. And of course, there's some roadmap we work on, which I think, as we discussed here, supporting higher level resources like application CRDs and Helm charts. And I think that's, I apologize for using all the time. Sorry for my poor network here, but you know, feel free to reach out to me or anyone at Kasten if you have questions on Kanister. You know, we'd love to start more conversations and keep these talks going. So.
Anyone has any questions? I know we're running out of time.
So are the action sets like cluster level resource, or are they namespace-scoped resources?
They're namespaced with the Kanister controller. And so if you can have multiple Kanister controllers running in different namespaces, and they'll only respond to action sets in their own namespace.
Okay. Thanks.
But good question.
All right.
Thank you.
Thank you, Tom. Everyone, if you have any topic you want to go through, please feel free to reach out. I'm sorry, Ashish, we need to postpone yours to next session. Thanks to everyone for attending. Thanks everyone for attending. I will upload the video, and you guys stay safe and healthy home.
Thanks everyone. Take care.
Thanks. Bye.
Bye everyone.
Bye.
Goodbye.